So let's also demonstrate how we can use this setter method right here inside of our customer class, and change the address to something new. So we can use this customer3, which has its current address like this, and what we can do is customer3, and we can say setAddress, and we can specify the address. So it's pretty simple idea, but the address itself, right? Address itself, we need to create as a new object, because this, for instance, here we are expecting something new. So let's create new address like this. Okay, and we'll use a different set of parameters. Let's just change this to Newport, Rhode Island, something like that, and whatever the Newport zip code is. For example, 2840, something like that. Okay, so the idea is that we're constructing a new object, and I think I have this extra part. Okay, so we're constructing new address object, and we're giving our customer 3. We say customer3 set address, and this is the new address. So at runtime, when we start this application, of course, what we get is that the new customer named customer3 is constructed, and so this gets a reference to our class name customer with all of these data attributes. So let's just display this result, right? So we construct this object right here, populated by these data attributes. Its constructor, of course, populates the address object with its own data attributes, and right here address is pointing, right? We have a reference to this object from our customer. But then we create brand new address. Okay, so this brand new address is brand new object that we create right here. So I'll just draw it right in place where we use the new operator. So we create new address, and then we tell our customer in our set address that this should be now your new address. Okay, so we make this change, and of course, because we're replacing this reference with the new, with reference to the new object, we kind of lose this connection with the original address. And once again, as soon as we lose connection with an object, we no longer have any references to it, this object will be garbage collected, because it will be considered to be no longer used. Therefore, it's just taking up space in memory, and garbage collection Java virtual machine thread will eventually get to it and free up memory allocated here. But the integrity of our customer is not affected, because now it just simply switches to use the new address object that we created right here. So in Java, every object which is created by new, and as long as we hold references to them, they stay in memory and we can continue using them. So we have used a number of methods in our application already right here, which are all represent sort of like specific methods designed to work with and provide functionality of our object customer. In the address class, we only had the constructor defined, but of course we are very likely also going to add getters and setters in the future, so that we can access individual pieces of the address class. Let's consider also an idea that we have constructors defined in both customer and address classes, and these constructors basically designed to expect certain parameters convenient to populate the set of data attributes. But there could be other constructors that we could use inside of our classes. For instance, a default constructor may look like this. Public address and just no parameters. Okay, so constructor that has no parameters, I haven't implemented it yet, right? I could just copy and paste this, actually this portion of the code, and change it to something like this and say that in the case of a default constructor, my street address will be unknown, like this, right? The city will be also unknown. The zip code will be maybe 0, and the state will be also unknown. Okay, so I may define it like this. So perhaps I am planning to use this poorly initialized version of the address in some instances where we simply don't know what the address is. So it's a possibility. So I can define it like this. And constructor is a method inside a class, and methods can have the same names, just like this constructor. The two of these constructors have the same name, and in such case the methods must differ in the list of their parameters. The return type is not important, it's just really that the list of parameters has to be different. Of course, in my case, this constructor has no parameters, right? It's just empty parentheses, and this constructor has as many as 4 different parameters. So of course, constructor will just consider them to be two different constructors, and so the idea of reusing the same name when defining methods is called method overloading. So these are two overloaded constructors because they of course have the same names, because this is how constructors are recognized, by the fact that they correspond to the name of the class, but they differ in their parameters. By the way, a constructor that has no parameters is called default constructor, and constructors that take some parameters are called specific constructors. And so some of this terminology is reflected in our handout. So these are examples of just product class, which is very similar, and updates that we make over there. Now, this keyword that we already made usable in few instances here has a few more ways that we can make it pretty helpful. Would be that we could delegate the work from one constructor to another constructor by simply using this keyword. So right here we can use constructor syntax and delegate the work to another constructor. So notice that we have, so I'm just going to sort of like modify my code right here to show you, and this will be another comma, and this will be a call. So here we're specifying, and again I'll format everything, so that we're specifying that we'd like to rely on the functionality of this specific constructor, and when we use default constructor, we would like to delegate the work to this constructor by simply using unknown street address, unknown city, 0 zip code, and unknown state. So the syntax is that you use this keyword and use the constructor syntax, and basically it will be what the compiler will produce as a code, that it'll just use this constructor to initialize your object with these parameters, we should be able to compile it just as before. So this is the second type of use of this keyword, besides referring to the data attributes inside our object when we're executing methods of our classes. So this is an example of the second use right here. Okay, and these are examples of the reference to an instance variable in the current object. We can also pass the current object to another method, right? So we can basically write some code where we take the reference to our current object and pass it to another object, to the method as a parameter to another object. And we can also pass our object to a static method. So as we continue working on different examples in the future, we will be able to demonstrate these two types of method calls in the future as well.